Hi everyone. Sorry my last video got interrupted. Just the fun of having kids and dogs and all kinds of fun stuff. So, backing up, we are doing inverse sine problems. Inverse sines, go forward. Inverse sines, they're angles that you respond as an answer to an inverse sine. Either comes out of quadrant 1 or quadrant 4. Quadrant 1 angles where sine values are positive. Quadrant 4 angles are where sine values are negative. And when we talk about the quadrant 4 angles, we're going to use their negative names. So, we already did these in class on Thursday, but I'm going to go through them again. Arc sine of negative root 2 over 2 is negative pi over 4. Root 2 over 2 is the sine in the pi over 4 family, but we're talking about the negative root 2 over 2, so that has to be in the quadrant where sine is negative, in quadrant 4. Arc sine of root 3 over 2, pi over 3. Arc sine or inverse sine of negative 1, negative pi over 2. You may remember I mentioned in class, there aren't that many answers that we're going to be able to do for these inverse trig function problems without a calculator. We're always going to be restricted to looking at two quadrants. One quadrant to look in for when the number value is a positive value, and we get the angles in that quadrant. The other quadrant to look at when the number is negative. Now, what we finished in class on Thursday but didn't go any further with was we had talked about that the arc's cosine, after we created the graph, and the graph is in these notes. We created the graph, back up for a second, there we go, and did the same process as we did with the inverse sine. Created the inverse cosine graph, realized it was not a function, talked about that we were going to have to use a restriction. We have to use a different restriction for inverse cosine. If you try to use the same restriction as inverse sine, that doesn't work for inverse cosine because of the curve. So 0 to pi is my restricted range. That means, if we're going to go summary, arc cosine, quadrants 1 and 2. Range is 0 to pi. Quadrant 1 is where we go when we're talking about places where cosines are positive. Quadrant 2 is where we go when cosines are negative. So we are going to need quadrant 2's angles. 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi, along with pi over 2, pi over 3, pi over 4, pi over 6, and 0. Those are the inverse cosine angle answers. So if you want to try these for a minute, you can pause. I'm going to do them in just a second, but you want to pause. You can see, can you tell me what angles I'm talking about for each of these inverse cosine problems? Inverse cosines are a little trickier. We kind of get used to an inverse sine. The inverse sine of a negative number comes back as a negative angle, but that doesn't happen in inverse cosine. Because inverse cosine, we're looking at quadrants 1 to 2. We're looking at answers 0 to pi. The answer for question B, the angle that has that cosine, but in quadrant 2, is 2 pi, that's a lie, that's the wrong one. It's not 2 pi over 3, it's the 5 pi over 6. Okay. It's, remember, the ordered pairs around the unit circle can help us. Every ordered pair that belongs on the unit circle is the cosine and the sine of that particular angle. So over here in quadrant 2, 5 pi over 6 is the matching ordered pair for pi over 6, just a negative root 3 over 2, 1/2. You notice that a lot of this is coming back to familiarity with the unit circle. And so practicing your unit circle values, making sure you have the basic ordered pairs. If you can do the first quadrant of the unit circle, then you should be able to kind of figure out the other 3 quadrants in terms of what the ordered pairs are like. You should be able to know the angles. The fun part about this is we're not using quadrant 3 so far. So quadrants 1 and 2, okay, for cosine. Quadrants 1 and 4 for inverse sine. Excuse me, 1 and 2 for inverse cosine. 1 and 4 for inverse sine. Inverse cosine negative root 3 over 2, 5 pi over 6. Inverse cosine of 0, oops, at 0 degrees or 0 radians. My x value is 1. So remember, this is, you always have to remember that's rate. Oh, no, that's the 0 value. Oh, whoo, I made the mistake. I am not going to edit that out. Yeah, 0 is super tricky because 0 in radians and 0 as a value, I mean, it just looks like a 0. So you have to always remind yourself when you're doing an inverse cosine that that is the value of the cosine of some mystery theta. So if I'm talking about a theta that has a cosine of 0, cosine graph's a good place to go for that. Cosine equal to 0. There's lots of angles, but the one that fits in my restrictions is pi over 2. Inverse cosine of negative 1/2. This is quadrant 2. And this is the other one I was thinking for, 2 pi over 3. Being able to come up with these answers, part of it is knowing what portion of the unit circle you're looking at. Quadrants 1 and 2 for inverse cosine. Quadrants 1 and 4 for inverse sine. The other part of being able to come up with these answers is knowing how the values and angles match up. Knowing the ordered pair for each of the angles, or at least, you know, the first quadrant angles, because then you can transfer them to their other quadrants with adding negatives in there. So that we can be clear on when I'm talking inverse cosine of negative root 3 over 2, that that's in the pi over 6 family. So the bad news is if you didn't memorize that information, it's going to come back to bite you right here, and so you got to work on it. The good news is it's really not that much if you break it down. Once again, I kind of think about it. These are easy to do. Oops. No, I'm right. Okay. And then 1, 2, 3. If you're starting here, your x is getting smaller. Oops, I don't want to close these. Your x is getting smaller. Your y gets bigger. Pi over 6, pi over 4, pi over 3, pi over 2. Cosine sine. That's a really quick little diagram you can throw on a quiz for yourself, do a little memory dump and just jot that down. And then you always can look at it. Even if you're like, I think I can pick it out of my brain, sometimes just having that safety net helps. Writing it out helps. And how do you learn what that is? You write it a million times. Well, not a million, but you write it down a bunch of times. Every night, like, okay, I'm going to practice when you're sitting in class. Not that you don't listen in other people's classes, but if you're not listening and you're just kind of doodling, doodle this. Practice it. Then you can recreate it anytime you need it. All right, I'm going to end this part of the video, and part 3 is going to involve the tangent and inverse tangent.